One more application to calculate the rate of flow, the pressure, the velocity inside a tube. We have a gauge pressure. Okay, we use two tubes in order to calculate Q by calculating or by measuring the height H in the two tubes. Here, simply, I give an example. If we have one tube of the same section, if I put simply a tube, two tubes like this, you know, at this point and this point, we have the same velocity because we have the same section. A1 V1 equals to A2 V2. A1 equals to A2, so V1 equals to V2. As we have the same V and we have the same H, so we get the same P. So P at this point is equal to P at this point. The height will be the same because we have the same P will push up the water to the same level. In order to increase P, just we can put here this configuration like this. Okay, if we put like this, in this case, you have you increase the pressure at this side. We get more liquid in this tube than this one. In this case, we can find the difference of H between this side and this side, and we can find finally a relation between Q and H. We can calculate Q by measuring H. So we consider a pipe with internal diameter D equals to 40 millimeter, where we have if water flows inside with a velocity equals to V. In order to measure the volume flow, I want to find Q inside. The pipeline was equipped with two tubes immersed in the liquid. As you see, we have these two tubes, one opening at a facing either point A. As you see, we have one opening at A facing the current. It means we have like this. As you see in the figure, it's like this. As the point B is along the current lines. So here, as you see, at the point B, we have a velocity VB, which is equal to the velocity V. Okay, but at the point A is a point inside the curve. So at the point A, we don't have a velocity because we don't have a flow up. At a certain time, we have a steady state inside the tube. We don't have more flow. So at the point A, as A is inside the curve, we don't have a velocity of the point A, but we have a velocity of the point B. For example, if you put your hand out of the car while you are driving your car, if you put your hand like this, the pressure will be high, but the velocity at the point in your hand will be zero. Okay, so we have zero velocity at the point A. Anyway, so here by measuring the difference H of the liquid in the two tubes, we can reduce the velocity. Anyway, here I explain the program. Let's go. At the point A, the liquid has the same speed V as in the pipeline. At the point A, stopping point, the flow speed is zero. The 2 points A and B are at the same height, where HA equals to HB. We give the density of water and the density of, we have only water. And I give you the value of G. We start with problem 1. First of all, I will apply Bernoulli equation. You know, between A and B, in the case of A and B, we have a flow of water. We have Bernoulli equation, we have continuity equation. But between A prime as you see, between A and A prime, we don't have a flow of water. We have a slug. VB square. Simply, PA is in function of PB, the answer here. Okay. We go to the second question. Write the fundamental relationship of the hydrostatic, I mean between AA prime, B prime. Between the point AA prime, third, we have to write the same relationship of the hydrostatic between B and B prime. You know the relation between them. We have PA equals to PA prime plus rho G H AA prime, and PB equals to BB prime plus rho GH B prime. These are the fundamental relationship of the hydrostatic between 2 points in the same liquid, in the static state. Give the expression of V as a function of GH. I want to find V, I mean VB, in function of G and H. Okay, you know, you can come back to this one. I want to find VB in function of G and H. We can substitute the value of PA and the value of PB here, and we can find the relation of VB in function of G and H. Okay, so we can write PA equals to PB plus rho over 2 VB square. We can put PA and PB here. Okay. So PA equals to PA prime plus rho G H AA prime equals to PB equals to PB prime plus rho G H B B prime plus rho over 2 VB square. You know here, for the point A prime and B prime, we have the same P equals to PO. We can eliminate PA prime and PB prime, and we can write rho over 2 VB square equals to rho G H AA prime minus H B B prime. You know here, as you look well the figure, we have AA prime minus B B prime equals to H. Okay? So here we can write rho G H. We have to calculate it. So here we have rho over 2 VB square equals to this one. We can calculate now, we can eliminate rho and rho. We can find VB equals to 2 radical 2GH. This is a simple relation, very important. You know, we can calculate the value of H, and we can, by measuring the value of H, we can calculate or determine the value of V. If you find V, you can calculate the rate Q. Q equals to A times V. So it's a very simple relation between the velocity inside the tube and the value of H. By calculating H, we can determine V. By determining V, we can find Q. Finally, I ask you to find Q. Volume flow, where volume flow equals to A times V. You know A equals to pi R square equals to D divided by 2 square times V 2 GH. We have all the values of D, G, and H. We can calculate Q. The unit will be meter cube per second. Volume per unit time. Volume per time. Okay? So this is a new problem. In the next video, I will solve another problem to calculate H in function of Q. Okay?